we are going to look at a sample complete machine learning scenario. Okay. In the previous lesson, we look at a very simple situation in which we create a machine learning model, um, to predict the genre of music given the age of the visitor to the online shop, and then also with apart from the age, also considering the visitor's gender. So the age and the gender were the basis to do the prediction. That was a very small project. In this case, we are going to look at a much larger size of a project, and by the end of this project, you should be able to fully understand and appreciate the area of machine learning very well. So we are going to look at every other case that comes with developing a complete machine learning project. So quickly, let's get into it. Right. So in working with real data, there are several sources that you can have access to public data that you can use. Number one, you could have some popular open data repositories like UC Ivan Machine Learning Repository. You can also have access to Kaggle datasets, Amazon's AWS datasets, and then you can also, number two, get data from meta portals. Okay. For example, dataportals.org, open data monitor.eu, Quandle.com, and then some other listing many popular open data repositories like that of the Wikipedia's, the Quora.com question, and then datasets subreddit. Okay, so if you need data to do any of your machine learning projects, you can have access to data from these sites. All right, so quickly, what we're going to look at next is to really look into the task at hand for today. The quick objective we're trying to establish in here is to build a model, is to build a model of housing prices in California using the California census data. Right, this data has metrics such as metrics or fields or features such as population, median income, median housing price, and so on and so forth for each block group in California. Right, so to understand this better, we want to help you appreciate what these block groups actually are represented as it is in California. Right, they are smallest geographical unit for which in U.S. Census Bureau publishes sample data, and most of the time the population spans between 600 to 3,000 people within that particular encampment. All right, so the model we are trying to develop should learn from this given data, and then be able to predict the median housing price in any district, given all the other matrices. Okay, so it will get to a point that we will not want to consider all the matrices or all the features, but some of the most important or relevant features. Now, to build or construct a machine learning project, you would need to frame the problem. Exactly what problem do you want to solve? So you want to ask the question, what exactly is the business objective? How does the company expect to use and benefit from this model that we are looking at creating? Right, so like we mentioned earlier on, the very objective for this is to predict prediction of a district median housing price. Okay, so that is the major focus in here. So the side from this diagram, there are two components: the district pricing and then the investment analysis. So where is our section? Our section, which is labeled in here as our component, is to make use of this district data set. So then we'll come up with a model, and then the functionality of this model is to predict the district pricing, okay, of a particular house. Now what we're looking at is that maybe at the end of this particular project, coming up with a model, we're going to have some set of district prices, and then this particular data would be relevant for some investors, and then the investors will want to, or there could be a second system that is supposed to take these district prices and then do some investment analysis. And then what will be the essence of this? Investors can have access to that information and then tell whether this area is good for them to invest in or not. Okay, so the output from the model we are trying to create can be an input to another system that will help investors know which area or encampment within of California they would want to do investment. Okay. All right, so quite apart from trying to establish, to understand exactly what the business objective is, and then how the company will tend to benefit from the model, we want to also look at another side of it. How does the current solution look like? You need to understand the present situation before you build a model. How does the current situation look like? Number one, it is understood that it is what? Costly and then time consuming. Okay, you will need to pay experts, human experts, to come around, and then it takes a lot of time for them to be able to come up with results. Okay, and also the results that they bring out, they are not the ultimate results. Why? Because the volume of data that they would need to consider before they come up with the pricing per district, it is that much a cumbersome job that regular human beings will do these things, and then there will be no deviations. So there are huge deviations that come up even with these human experts having to do these jobs, right? In cases where they even manage to find out actual median housing price, they often realize that their estimates were off by about 20%. So this tends to be a very good motivation why the machine learning model needs to be created. So then we can try to zero out this 20% deviation that comes from the human expert needing to coming up with the predictions on the median housing pricing. Now you need to move on further to create a design of our component, which is now supposed to serve as the model to do the prediction of the median housing. So number one, in framing the problem, we have come to agree that we need to understand the objective of the company and then also look at the relevance, how it's going to help them. Further on, number three, we will need to understand to know, is this kind of project going to be machine learning system going to be supervised or unsupervised? Is it going to be reinforcement? Right? You need to also come to a conclusion on whether it is a classification tax, it is a regression tax, or it is something else. Right? And then you need to also know which learning scheme you want to use, whether it's supposed to be batch learning or online learning, or exactly which kind of learning scheme is it going to be. We're trying to find answers in here. In our case, it is typically going to be a supervised learning. Why supervised? Supervised because the data, if we get to the side where we open up the data, we tend to appreciate the data has labels. Okay, the input features are labeled, and then also the class is labeled. That the class is also available in the data set. So that makes it what? Supervised. Number two, it is a regression tax. Why? Because we are going to predict what? Predict a value. What value are we going to predict? We are going to predict the housing price. That is what we are trying to predict. In much specifics, it is going to be a multiple regression problem. Why? What is the justification to this? This is because there are several features that makes up the data set, and we're going to base on more than one feature to do the prediction of that singular value, and that makes it what? A multi-regression problem. Also into more specifics, it is a univariate regression problem. Why? Because we are predicting only one value for each district. Okay, uni. So just one. It's a univariate regression problem because we are going to predict just one value. Okay, and then also to answer whether we're going to use online learning or batch learning. Right? In the previous in the previous studies, we have clearly distinguished between batch learning and then online learning. If you have not watched that video yet, I would recommend strongly that you go back to the previous video and then you watch that. You get much understanding, in deeper understanding into the different learning systems that are available in machine learning. All right, so quickly back again into this. We are going to use the batch learning. Why are we going to use the batch learning? Because there is no continuous flow of data coming in the system, and then there is no particular need to adjust to changing data rapidly, and the data is small enough to fit into memory, right? So we will not need to break the data into some smaller units and then sequentially bring them into the learning algorithm, introduce them to the learning algorithm to begin to learn from it. This is the very reason why it is going to be what? It is going to be batch learning. Quickly, what we're going to look at, quite apart from framing the problem and then coming to understand whether it should be supervised, unsupervised, reinforcement, whether it's supposed to be classification or regression, and then also which learning system you're going to use. Once you have been able to answer this, we would need to also come to a conclusion on what metrics are we going to use in measuring the performance of what? Of the model that we have created. Okay, so we have about 3 sets of matrices that could be used. I'm going to quickly run you through it. Right, so we have number 1, the RMSE, which represents the root mean square error. Right, it gives an idea of how much error the system typically makes in its predictions, with the highest weight of large errors. So this is the mathematical representation of the metrics that we'll be using. We'll spend more time in explaining these matrices, but for this particular video, I would just need you to appreciate that we have a matrix of measurement or performance of the learning algorithm, which is called RMSE, representing the root mean square error. And then we also have the mean absolute error. Okay, the mean absolute error is given by this mathematical representation. As compared with the RMSE, the MAE are ways to measure the distance between two vectors. Okay, the vector of predictions and the vector of target. Okay, so you have the values you want to predict. You have the target values that will help you do the predictions, right? So you want to measure the differentiation between what has been predicted and then exactly what was the target, and then by that you're able to come into a conclusion on what is the performance of the learning system. All right, so apart from the RMSE, we can also use the MAE to measure the performance of the model, right? All right, so quickly we're going to look at some final concept on these theories, and then we'll move on to the next video where we'll learn really how to do this using Python. All right, so quite apart from modeling, framing the problem, understanding the problem, and then also knowing which matrices to use, quickly we need to also be clear with some possible existing assumptions. All right, if there are any assumptions, the assumption needs to be listed and then verified. For example, the district prices that the system output is going to be input into another learning system, and then we assume that these prices are going to be as such. All right, so if they are going to be input into another learning system, that would also inform how the project is going to be undertaken. Like I explained earlier in the previous slide, that our component would generate some kind of results which actually or primarily will contain the district housing, median housing prices. Now, these values of prices per district may also be relevant for investors. If some investment analysis is done on these values, investors will want to see which areas within of California they would want to do what they would want to invest in. Okay, maybe they want to build more estates, or which specific lines they would have to tow. Right, so these assumptions need to be clearly well established before the project kickstart. All right, so we're moving away from the assumptions. we will want to look at how we would have access to the data, right? So this is the link that we're going to use to have access to the data. And then in this work, what I'm so much happy is with that, as in the previous example we looked at in creating a model to predict the genre of music that should be recommended to a new visitor to the online music shop. That data was typically on our local machine. Okay, so we didn't have to go through any hustle in getting them for the learning algorithm. But in this case, we would not want to download the data before usage. We want the data to sit in this repository. We would download the file, and then we would pass it on to the learning algorithm to look at it. It is going to be that exciting. Hold on, and then you watch the next video. Thank you.